How are you doing? My name is Oluwale Godwin and welcome back to Economics. Optimization of functions using derivatives part 3. Now this is where everything I've been trying to do on calculus is going to begin to make sense. Alright, so we talk about when we will start discussing maximum points, minimum points, so what are their economic interpretations, what do they mean economically. So here we have an exercise that says maximize profit by, okay, that's the sign for profit for a firm given the following. So you have a demand function. So when you have something like that, P starting something, so it's usually a demand function. And if it were meant to be a supply function, this would be QS. There is something to denote, to differentiate, but here it is just P. So we are assuming that this would be QD. So this is a demand function, and you have a total cost function, which is 2Q raised by whatever it is. Now we have to maximize profit. Now profit is not in the 2. So which is part of what makes this question a fantastic question. So we start. So how do you calculate profit? Profit is this. Profit is simply total revenue minus total cost. Alright, but we have total cost in the question. So what is our total revenue? Now total revenue is simply price multiplied by quantity. Okay, now we have price, which is representing the entire demand function. So price is a function of quantity demanded, right? So we are going to multiply this demand function by Q. Alright, so TR now is going to be, this is P, right? So P will be 4,000 minus 33Q. So there's no point in, you can just take it out, multiplied by Q. Alright, so the price function multiplied by, which is the same as demand function. So this is going to be 4,000 Q minus 33Q squared. Now this is the total revenue function. Now we have total revenue and we have the total cost. So profit now, let's continue, equals TR minus T, which you've written before. So profit equals, this is TR. So I can just say 4,000 Q minus 33Q squared. Okay, minus what is the total cost? Total cost is 2Q raised by 3 minus 3Q raised by 2 plus 4,400Q plus 5,000. So we simplify this to make life easier for ourselves. So this is going to give us 4,000Q minus 33Q squared. Okay, so minus 2Q raised by 3 minus times minus is plus. You have to be very careful at this point, because once the signs are not correct, everything that you're going to do is wrong. It's going to be wrong, because this is just the beginning. Then minus times plus is minus 400Q, minus times plus is minus 5,000. So we collect like terms. So when we collect like terms, so when we collect like terms, what are we going to have? So the profit function is going to be, so we have Q squared here, we have Q raised by 3 first, which is the highest power, minus 2Q, then minus 33Q squared plus 3Q squared, then plus 4,000Q minus 400Q minus 5,000. Let's count. 1, 2, 3, 4, 5, 6. 6 elements. 1, 2, 3, 4, 5, 6. Alright. Now the profit function is minus 2Q cubed minus 33 plus 3 is going to give us minus 30Q squared plus 4,000 minus 400 is 3,600Q and minus 500. So let me check that in my notes. So you have minus 2Q cubed minus 30Q squared plus 3,600Q minus 500. Alright, so this is now the profit function. Right, so this is what we're expected to optimize, or we're expected to maximize. Alright, so we then start. So we've not done anything before, then start. So we find the first derivative, that will be the pi, okay, the q. So we are differentiating profit with respect to quantity demanded, and that will be minus 6q squared minus 60q plus 3,600. Yeah, minus 6q squared minus 60q plus 3,600. Now good. So what we just have to do now is to, okay, the pi, the q equals 0 as what? Optimization points. Optimization points. So when we do that, we'll be having minus 6q squared minus 60q plus 3,600 equals 0. equals 0. So minus 6q squared minus 60q. So because I'll be using the general formula, so this is the equivalent of q squared is minus 6. That will be our a. Minus 6, the entire minus 6 is our a. Then minus 60 will be our b. That's coefficient of q. Then this is going to be our c. The constant will be our c. So what we're looking for here is not x like we did in the previous videos. What we're looking for here is q. So we q this minus, so we have b squared minus 4ac, everything divided by 2a. So q equals what's b is minus 60, so we're having minus 60 plus or minus 60 squared minus 4 into brackets. What is a? What is a? A is minus 6, and what is c? This is extending here. C is 3,600, right? 3,600 plus the bracket. So everything divided by 2. Then a is minus 6. Please use your calculator here. So minus 60 gives us 60 plus or minus. So we have 3,600 minus times minus is going to give us a plus. 4 times 6 is 24, and 24 multiplied by 3,600 will give us 86,400. So we have 86,400. So everything divided by minus 12. So 2 times minus 6 is minus 12. So we'll be having 60 plus or minus 90,000 divided by minus 12. So this is 60 plus or minus root 90,000 is going to give us 300. So everything divided by minus 12. So this simply means we have 60 plus 300 divided by minus 12, and then we have 60 minus 300 divided by minus 12. So this gives us 360 divided by minus 12, which is minus 30, and this gives us minus 240 divided by minus 12, which is what? 20. So we have our quantity. So q equals 30, and q equals minus 30, and q equals 20. So now what we have to now verify is which of these is actually maximizing profit. Which of this is maximizing profit? There are times when the quantities will be both positive, so q might be 30 and q might be 20 as well. Alright, but here we are lucky. Quantity produced or quantity sold cannot be negative. So this is already an indication that this is likely going to be the one that will maximize profits. But we don't know until we verify. Please, if you have a question like this, make sure you verify. Don't just jump to conclusion that because quantity cannot be negative, so q equals 20 must be maximizing profits. It doesn't work that way. So we have to verify. So how do we do that? So what we just have to do in that case is to find the second derivative of the profit function. So when this was the first derivative, so second derivative would be d squared by then the q squared. Okay, so from here that will be minus 12q, okay, then minus 60, minus 12q minus 60. So when q is minus 30, so q minus 30, so this squared, I'm trying to save space, the q squared will be minus 12 into bracket minus 30 and minus 60. So minus 12, this is going to be 360 minus 60, which is 300. Now 300 is greater than 0. So if 300 is greater than 0, so that means this is positive. Then remember that we'll be having this point. Okay, this is positive. We might be having this point. Okay, and which means profit is not maximized. We have a minimum point. So this is minimum. So that would be a relative minimum. So when quantity is equal to minus 30, the function exhibits a relative minimum, and then it is convex. Okay, the function is convex. Now let's verify for q equals 20. Now when q was, okay, let me just say when q, let me make this equal to minus 8. So when q equals 20, so the squared pi, the q squared pi, the q squared is going to give us minus 12 into bracket 20 and minus 60. So this is going to give us minus 240 minus 60, and then we'll be having a minus 300. So minus 300, okay, let me just, minus 300 is what is lesser than 0, that is, it is negative. So if it is negative, it's trying to tell us that the second slope now is like this, so which means coming from this point. So it simply means a relative maximum. So that's a relative maximum, and then it is concave. Why there is in the second one, the function is concave. The function is concave. So the economics of all of this is that the profits of this firm is maximized when the quantity produced is 20. Okay, the quantity. So this is, after you've done the mathematics, I'm just telling you the conclusion that must not be exempted in what you've just done. So the conclusion, you have to conclude, and the conclusion is that given the demand function of this particular, or just say given the profit function, because of the profit function that we obtained here, given the profit function of this particular firm, profit is maximized when the quantity produced is 20. So nothing more than 20 must be produced and nothing less than 20 must be produced. So if the quantity produced were less than 20, it has to be increased until it gets to 20. And if the quantity produced were more than 20, it has to be reduced to 20 units to maximize profit. So there are some questions I would ask you to, like, based on what you've done, to render advice to this particular firm, and that's what I've just said, that this firm should produce where its quantity is equal to 20, because that is where profit is maximized. Now that's what it simply means is that, so this is the graph, this is the maximum point, and this is going to be 20. So where this is Q and where this is profit function. Alright, so profit is maximized. You can see from here that if this person produces more than 20, is already on the falling part of the of the profit function, or the profit curve. And if it produces less than 20, it is not yet up to, it's because I didn't draw it well, it's not yet up to the maximum profit that it can make. So you see that this is why we make use of, or this is one of the reasons why we make use of mathematical economics in this is one of the reasons why we make use of derivatives in economics, in mathematical economics and economics in general. So this is one of the reasons. So from here henceforth, economics, all of these things should start to make more meaning to you. Now here I intentionally made this a demand function. You might be lucky enough that you just be given the total revenue function in your test or in your exam. So in that case, just the total revenue minus total cost, you get your profit function and you continue. And sometimes you might be given the profit function itself, so you continue. But here I'm trying to look at what's the difficult way, because some lectures are just naturally difficult. So what is going to be like a difficult or a technical way that some might want to set questions. And I think I just came up with this. And if you are given an MC function, a marginal cost function, instead of a TC, you might be given a fixed cost. You have to be given a fixed cost, and maybe we'll do a video on that as well. So there you have to integrate the marginal. When we get to integration, when we get to integration, we should talk about that. Alright, so see you in the next video. Make sure you like this video, click on subscribe, turn on notifications. Now everything is just free. Share with your friends, share with your colleagues. Now let everyone in your school, let everyone in your department know about Economics, so that everyone's grade is going to be better and people keep excelling. So thank you once again, and see you in the next video. Hope you enjoyed the video you just saw. If you want more of our videos, please make sure you subscribe to the channel and click on the notification bell. Now there is a way to enjoy, to make the best of our YouTube channel, which is to go to the playlist section of every video or of every topic. So what you have to do is just type Economics on YouTube. When the page displays, make sure you subscribe. A bell button appears immediately, so you click on that bell button. Then go to the playlist section. So you are going to see videos, playlists, description, and all of that. So just go to the playlist section, and whatever topic you are looking for, look for the playlist and click on the video. Now our playlists have their classes, have the classes arranged in a very chronological manner. So if you want to see a class on ISLM, so it starts from the beginning, the simple ones to the difficult to the complex ones. So if you want to see a video on, let's say, elasticity of demand, so you start from what is price elasticity, so from there then to the basic ones, and on and on. So I'm just telling you that in case you really want to make the best of this YouTube channel. And there's also one thing that I want to add, which is that our YouTube classes may not be enough for you. You may want a regular interaction with the tutors and all of that. So what you just have to do is to check the description of the video. You are going to find a WhatsApp link. So but before you do that, I really have to tell you that clicking that link is going to lead you to one of our schools. It's going to lead to some of our schools. So we have MOG School of Economics on WhatsApp, and we make use of our YouTube channel to run the groups. So the classes are paid for, so you're meant to pay for them. So to join our Econometrics school, so that is 2,500 naira per month, and to join our Microeconomics or Macroeconomics schools, so that is 2,000 naira per month. We also have we don't have classes, or we don't have schools of mathematical economics, because microeconomics has its mathematical aspects as well as macroeconomics. So those mathematical economics aspects of the two economics, no. So the mathematical aspects of macroeconomics and microeconomics are treated together in this. So the mathematical aspect of macroeconomics is treated in the macroeconomics school, and the mathematical aspect of microeconomics is treated with the microeconomics school as well. So I'll see you next time. Thank you very much for watching. So the mathematical aspect of macroeconomics is treated in the macroeconomics school, and the mathematical aspect of microeconomics is treated with the microeconomics school as well. So I'll see you next time. Thank you very much for watching.